So here we go. All right. So I must get a pen. All right. This says the gas laws. Yes, you may. This says the gas laws. Boyle's law looks at volumes and pressures, and everything else is held constant. So the amount of gas is held constant, and the temperature, Zoe, is held constant. So now we're just looking at how do volume and pressures relate when you have the same amount of gas and the same temperature. And that's called Boyle's law. Okay? It says to us right here that the volume of a container, and I'll grab the highlighter. Okay. Okay, so it says up here that the volume of a gas varies with the pressure inversely. So that means an indirect relationship. When one goes up, the other goes down. An indirect relationship. All right, so let's see if we can fill this in. It says if we have a volume of 5 liters and the volume changes to, 0.5 liters, and it changes to 1 liter, what have I done, Laura? What have I done, Laura, to the volume? I've increased it. How have I increased it? Okay, so I went from 0.5 to another 0.5, so I doubled it. Okay, so if I double the volume, Thomas, what do you think happens to the pressure if they have an indirect relationship? One goes up, the other goes down. One goes up, the other goes down. So if the volume gets doubled, what's going to happen to the pressure? If the volume goes up, the pressure goes down. Okay, so Andrew, can you give me a value that it might be? Okay, so 100 kPa. See, what happened here was the volume doubled, so the pressure got cut in half. That's what it means to have an indirect relationship or inversely proportional relationship. If one of them gets doubled, the other one gets cut in half. So one gets multiplied by 2, the other gets divided by 2. Okay? All right, so let's do it again. Let's go from 1 Kiara to 2 liters. What happened to the volume? Okay, it doubled again. So Hunt, what happens to the pressure now? It gets divided by 2. So 100 divided by 2 is 50. What that tells us is as volume increases, pressure decreases because you're allowing the particles to be in a larger container. That means they won't hit the container walls as often if you're in a bigger space. Okay. Balloons are hard to talk about because balloons are flexible. So that volume is constantly changing in a balloon. Can we go create 3 dots and then connect those 3 dots with some kind of graph line? Well, let's see. Your first line is 0.5 liters at 200 kilopascals. So 0.5 liters at 200 kilopascals would be up here. That's my first dot. 1 liter at 100 kilopascals. 1 liter. What am I doing? Did I put on 250? I did. Sorry. Yeah, you're right. And I'm all off anyway. So this is a half at 200. It's a little off. Okay, there we go. And then at 1, is that 1? Is that 1? That's 1. 1 at 100. So 100's right here. And then I'm at 2, which is right here, right? 2, and I'm at 50. Okay, that's going to give me this kind of relationship. Have you seen that in math before? That's called an inverse graph. A graph that's showing two variables, the dependent and the independent variables, and they have an inverse relationship one to another. That is pressure and volume when we are dealing with gases. Pressure and volume, Jaquan, when we are dealing with gases. Okay? All right, let's do the next one. Now, that was called Boyle's Law. Not that you have to know he's called Boyle's Law. Let's look at the next one. The next one is Charles's Law. Charles's Law says the volume of a fixed mass of gas, the volume is directly related or directly proportional to the Kelvin temperature. So volume and temperature have a direct relationship. One goes up, the other goes up. Direct relationship. One goes up, the other goes up. One goes down, the other goes down. It's a direct relationship. So if one gets doubled, the other gets doubled. If one gets cut in half, the other gets cut in half. That's what a direct relationship means. And when we're talking about a constant pressure, pressure not changing, temperature and volume have a direct relationship. So let's see if we can fill in our charts. So Nate, help me out. I go from 100 Kelvin temperature to 200 Kelvin temperature. My volume goes from 200 milliliters to what? 400 milliliters. Thank you. All right, Lauren, I go from 200 Kelvin to 400 Kelvin. My volume goes from 400 milliliters, 800 milliliters. Thank you. And so we fill in the statement here. As temperature increases, volume increases. Now, one of the things you got to change on my graph over here is that says liters. So if you'll change my little typo, my little mistake, to milliliters, I'd appreciate it. Now again, Hunter, we're finding 3 dots. We're finding 3 dots. Zoe says, leave me alone. I'm trying to concentrate. Oh, good. Okay. So we're trying to find 3 dots, and we're trying to see. This one was indirect. This one's direct. So they're going to be different graphs, right? Okay. So if I have 100 Kelvin, I go up to my 200, and I cannot read that. What's my first one say? It says 200. All right. Okay. mLs. Good. And then if I have 200K, which is right here, I have 400. Where is 400? Right here? Okay. I can't read it from here. And then if I have 400K, which is right here. Okay, I cannot read that. 400, and then I have all the way up here at 800 right there. Okay, what kind of graph do I have? Linear. A linear graph. Y equals mx plus b, yes? Yes. Okay, so I have a straight line. That's the direct relationship versus the indirect relationship when you look at the graphs. Okay? Now, for the video's sake, I'm just going to make the statement for everybody watching the video, since we need to stop it because of time constraints on the video, that the next graph is also going to be a direct graph. And we're going to do that without